Okay, let's pick it up where we left off, and we're going to talk a little bit more about recursion. And you may remember that we wrote an iterative algorithm for reversing a string, to reverse word to draw or draw to word. So how did that work? We took the first letter and the last letter and we swapped them. And then we incremented one, decremented one, swap, and kept going until we got to the midway point. And it was an iterative algorithm. We had either a while or a for loop that would work its way from the first letter to the midway point of the string, swapping, 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 swapping. Perfectly fine way to swap. And I just want to think about this, how we would do this recursively. So what does it mean to recursively reverse a string? Well, as you saw with the factorial, typically what it means is that you keep simplifying the problem until you get to a base case. So what does a base case look like in reversing a string? What's the easiest possible thing? Well, a string with only one letter is trivial to reverse. It's that letter. Or maybe the empty string is a trivial base case. So that's always good to think about when you think recursive is like, what's the simple case here? And then your job recursively is to take a problem that is big, reverse a string with n letters in it, and figure out how to break that down into a simple operation with a slightly simpler version of it, say reversing n-1 characters. Right? So let's just think about that. So what does it mean to reverse a string? So we had been thinking about this as I swap the W and the D and then the A and the R. But the other way to think about this is I can just take that W and put it all the way at the end and then reverse the rest of the string. Yeah, that sounds about right. So let's see if that makes sense. So can we agree that the reverse of the string word is the reverse of everything but the first letter, string concatenated with the first letter? Sure. Let's just do this in our heads. If I reverse this, it's DRA, and then I attach a W to it, and that's, of course, the reversal. So notice what I've done here. I've simplified the problem by one letter, and I've done that by thinking about the nature of what reverse is, by just saying if I just take that first letter and put it at the end, and then I'll worry about the rest of the string later, that's a recursive definition. Because notice I've defined the reversing of an entire string as the reversing of a slightly smaller string plus a simple operation. Looks a lot like the factorial, right? N factorial was n times n minus 1 factorial. All right, let's just do it again to make sure we see how we reverse now ARD. It's the same game. Take that A, shove it to the end. Now, not the end here, of course, the end of this, and then reverse RD at the front of that. So the reversal of ARD is the reversal of RD plus A. Now, eventually, so notice what's happening. This thing has to evaluate to this. This will eventually give me an answer when I work my way down the recursion. I'll shove it in there. It should be DRA. I attach a W to it, and then I'm done. Okay, what's the reversal of RD? Now we know what the game is. Take that first letter, shove it to the end, and then reverse a single letter. This looks like the base case I mentioned. If I have a single letter, reversal is trivial. There's no work to be done. There's no computation. It's just the letter. So let's agree that the reversal of D is just D. Base case, no recursive call. This is like 0 factorial is 1. No work to be done. All right, now what you have to do, notice what we've done. We've built up an expression with a series of string concatenations, and now we've just got to work our way back up this stack in order to create the final answer. So let's start at the bottom, of course. What is reverse of D? It is D. And so reverse of RD is just the string concatenation of D and R. Okay, that's easy. I know how to do that. Now, there's no recursive call here. There's no work to be done. Just do the string concatenation. So the reversal of RD is DR, and I'm going to concatenate that with A. Good. Let's do that. So D plus R plus A. The reversal of ARD is DRA. So we pop that back up 1, and now we have the reversal of word is DRAW. And again, we've done that. And notice it's really a different algorithm in this case, right? So instead of swapping, I am building up an expression of string concatenation by one at a time, peeling off one letter. And that's what I meant when I said at the beginning of the previous lecture that recursion, you have to think really quite differently about the nature of computation, and I think in a very elegant way. All right, now let's do it in Python. Reverse is a function that takes as input a string s. Base case, if the length of the list is 1, then return s. There's nothing to do, right? I sent you in the letter D, The reversal of D is D. Go home. You're done. Otherwise, what am I going to do? I want to peel off that first letter and put it at the end and string concatenate the reversal of the rest of the list. So remember that, remember that strings can be indexed like lists. Here's where it's very convenient. So S sub 0 is the first element of the list. And you may not have seen this notation before, but this one colon operator is shorthand for everything from the first character, in the character in the first position of the string, so that's the second letter, to the end of the list. So I could have also done 1 colon length of S, but this is a simpler notation that Python gives you that just says 1 colon and then you leave a blank here, and that says give me everything but the 0th element. Yeah, and that's perfect because now I'm going to take, let's say what comes in is word. I take the W, that's S sub 0. I take ARD, and I take ARD and I shove it back into a recursive call of reverse. Okay, what does that do? That peels off the first letter. And notice again, this is where it's really important to understand these local variables, right? The first S coming in was WARD. But when I make a recursive call, the new S is ARD. And then the next time it's RD, and then the next time it's D. And then this expression, the string concatenation, holds on to the memory of all those different instantiations of the local variable to the function reverse. Okay. All right, last thing is there's another base case. I just want to show you what it looks like because it's equally fine, which is you could have had the base case be the empty list. And it would have worked just fine. You would eventually hit the empty list. I don't think this is really necessary because a list with a single character is in fact, the reversal is itself. The only reason you might want to do this is if somebody passes you an empty list, it'd be nice not to choke on it. And so this is nice because it deals with an empty list problem. Okay, that is the second recursive example that we've done. And I hope you now see that not only does the code look different, but you have to think differently about the problem. And I really like that because it forces you to sort of think about the nature of computation in a really fundamental way. So we're going to do a couple more examples when we come back. I'll see you in a few minutes.